Bueno,
Buen día a todos.
Good morning, everybody.
Honor y placer poder estar coordinando este
It's
panel
a pleasure
con dos empresas
for me to coordinate this panel with two state-of-the-art companies, not only the world of biotechnology and AgTech, but also the level of businesses that these companies are developing to be main players in the agriculture for the future. I think that the objective of today is to try to take the most from this guest. I will ask Gansi if he can come to the podium and start with the first presentation of the panel, please. Thank you.
Good morning, everybody.
Buenos días. Quiero extender mis agradecimientos a los organizadores de ADKE por darme la posibilidad de venir acá a hablar un poco de mi empresa. Yo soy norteamericano, he vivido unos 15 años en São Paulo, en Brasil. Quiero empezar haciendo algunas observaciones sobre el sector y luego algunos detalles sobre los biosistemas para hablar.
Benson Hill really has a platform of technologies. They're involved in gene trait development, genome editing, and as well as breeding, computational breeding. And there's two core focuses of the company, and that's the natural genetic diversity is made accessible through its proprietary CropOS data processing system. And they have product development focus, which accelerate with machine learning and big data. And again, genome editing and plant biology combined, all anchored around the CropOS system. And I'd just like to make an observation here that that technology is really bridging across the value chain. You know, even 2 years ago, we were more focused here at the front end of the value chain, focused on yield and pest resistance, drought tolerance, and nitrogen use or efficiencies. In the course of 3 or 4 years or so, you really had a broadening and an explosion of interest here at the front end with consumers, food companies, beverage companies, where's been significant innovation. And so what we're really seeing is across the value chain opportunities in innovation. As one observation, for example, from the consumer, you've had an acceleration in terms of the purchasing power of millennials, which is equivalent in today's terms to the baby boom sector. And there's been an aggressive movement towards what consumers want. You know, a combination of natural issues, local supply, raised without antibiotics, non-GMO in general, and organic. I have a couple slides here that are just going to list a range of companies that are involved in the biotechnology space and agriculture. You know, this is a recognition from Tech Excel magazine, just recognizing innovators in the agricultural space. And if you take the time, the range really is broad, from genome editing to biostimulants, biopesticides, breeding, cloud biology, biotech traits, diagnostic and data analytics. It's really a broad range, and Benson Hill combines you know, several of these in its portfolio. Similarly, this is a collection of innovative companies recognized by Artificial Intelligence 100, and the ag component here to the left. And the reason to show these slides is not so much for the recognition for Benson Hill, but to really emphasize the dynamism and the activity that's going on in the ag biotech space, that it's growing, it's very aggressive and very innovative. And specifically, this slide is showing the combination of focus of many of these companies in the space. Some in microbials, gene editing, precision ag, indoor ag, in urban centers, which is one of the fastest growing both in North America and elsewhere. Alternative protein platform models, unique partnerships, and direct contracting. It's really a combination of technical innovation and business model innovation in these niche sectors. I just have a couple slides explaining a little bit the background of Benson Hill. The namesake is a combination of Andrew Benson, who contributed to the discovery of the Calvin-Benzil cycle, central to the photosynthetic process, and Robin Hill, who demonstrated the Hill reaction, which really effectively is focused on capturing solar energy in photosynthesis. And that's explains the origin of the name Benson Hill. The company was founded in 2012. I've worked with the company originally in an advisory role and more formally for the last couple of years. It's grown to over 70 members. The research and development is concentrated in St. Louis. The corporate headquarters is in the Research Triangle area. And we have presence in Sao Paulo, Brazil, Buenos Aires, and in Guelph, Canada. The funding is, that's original funding. We're actually in the final process of raising about double that amount of money in the third quarter. And the one thing I'd really like to emphasize here is the breadth of skill sets in the company. To the right here, it's really a broad combination of molecular biology, crop physiology, plant transformation capability, computational biology, breeding, quantitative genetics, and so forth. It's really the breadth of people. I don't know how easy it is to see here, but this is from our site page. And I just want to point out the presence of Matt Crisp as the founder and acting CEO. And it's a serious commitment and breadth with executives from across the industry, from the largest players, Monsanto, Syngenta, Illumina, and so forth, who share a mission to try and democratize technology and empower the small, medium, and large-sized players, farmers, and consumers in the space. This is just to highlight the part of the resources to the company that takes advantage from the Donald Danforth Plant Science Center in St. Louis. It's the largest independent research facility in plants in the world, and it has all these resources and facilities that Benson Hill is able to utilize. Just a couple of slides focusing in on the technology itself and the overall platform of the company. Crop OS is the trademark recognition of the data processing engine. And really what the company's focus is on capturing data, public data and private data of phenotypic, genotypic, and omics data. That's used really to drive the data analytics component of the engine, which generates unique proprietary data as a process and works as a predictive engine in data analytics and applied to three applications: breed, edit, and reveal. And then through testing and deployment, the system is tested further. The idea is that the approach has a significant impact on product development. There's a range of inputs involved across those three applications. It can be a predictive engine and analytics of Crop OS, proprietary genome editing chemistry, leveraging natural genetic potential identified through the applications, and testing and proprietary model crop. Ceteria is the benchmark crop for us. And then we have a short list of commercially focused crop testing, high turnover, high cycle kinds of crops for proof of concept for the technologies. And we're across hemisphere. We're doing field tests in both North America and South America. But the combination of these, the result is to decrease time to market by a significant amount and decrease product development costs. I'll talk a little bit about how that happens. Comparing, for example, traditional breeding to the breed and edit platforms of Benson Hill, you can see the significant difference in development times. And again, this makes some reference to that one of the earlier slides, and the idea is that Crop OS enables crop improvement opportunities to deliver a wide range of desired market outcomes. And a couple years ago, really the entire focus was on the left side here, was much more performance, yield, disease resistance, drought resistance, and so forth. But really, with the acceleration of genome editing technologies, both across Cas9 and CRISPR, but also of those that Benson Hill has patented, there's been an acceleration in interest in developing capabilities to change nutritional quality, from protein content to oils, to carbohydrates, fiber, and so forth, and also sensory quality, taste, color, texture, and even aroma. So it's really opened up exponentially the range of companies interested and affected by the space. So just quickly, I'll give one or two slides on each of the applications to try and demonstrate their background. This is just an observation about breeding, that natural mutations really result in the development of a range of breadth of crops over time. This is Basidica oleracea, and just demonstrating that this collection of plants that we recognize today are really originated from the same single source. It's a little bit difficult to read this, but this is sort of demonstrating that breed combines four key functions here. It's to integrate data, to visualize the diversity with a graphic component. The breed application is a software interface platform to be used as a tool by breeders. And so it's able to predict traits and then make selections of varieties. The interface really looks like this. This is the interface on the computer face, and it really combines a range of functions in the breeding process. It's a user-friendly workflow for genome selection and predictive breeding. So, combining evaluating germplasm to creating target sets, training sets, examine model performance and prolific phenotypes to make selections, to make selections more efficiently and more quickly, eliminating potential need for field trials, comprehensive field trials as well. And what's possible, it's a platform to every breeding decision can be incorporated. And one of the most recent functionalities introduced to the Symphony is dev cross prediction and line development here. I just have a couple slides that show a little bit of the functionality. This is the breed application dashboard, germplasm models, and so forth here. It's easily to explore the diversity from the germplasm view. This is just the tab for germplasm graphics, and it's 3D and rotational. The system allows you to build powerful models in 3 easy steps. You choose a training set, you choose from 5 different algorithms. You can input proprietary algorithms as well, and just click submit. So the design is to be very functional and easily manipulated. And then the models are ready for evaluation. This is the model tab used in the models view. And again, these can be publicly developed ones or proprietary. Another function of the platform is that it predicts phenotypes from genotypes. Again, in 1, 2, 3 easy clicks within the interface. I just to address the second technology platform, that is EDIT. This is just recognizing the patents that were awarded to Benson Hill for proprietary genome editing chemistry in February of this past year. They are focused on a combination of CMS1 nucleases and CPF1 nucleases that we categorized from CRISPR 2.0 and CRISPR 3.0 portfolios. And we have additional patents under review as well. And the range of application for the editing capability is really unlimited. I'm giving just 2 examples here where editing rice blast disease susceptibility in plants, for example, to confer natural resistance and displace the use of pesticides is one target. And the company is working both with collaborating partners, but also on its proprietary capability in a range of areas. Another example is editing saponin production to improve or alter the sweetness and nutrition and sustainability of quinoa, high-yielding quinoa. But again, just 2 examples of many kinds of applications in the genome editing space. And a final couple of slides on the Reveal application, which is really, the company has proprietary traits that it's been developing for commercialization, a range of portfolio traits, again, everything focused on optimizing the photosynthetic process, identifying gene traits that do this. And it really is a combination that the Reveal app has predicted viable trait candidates at a rate of 10 times the industry average in terms of its efficiency of identifying. And the number here show that you're really approaching high single-digit yield increases over several yield trials. And again, these have been field testing in both North America and South America. There was a public announcement as one example of empowering the farmer in May of this year, where a new trade partnership between Beck's and Benson Hill. Beck's is one of the largest, or is the largest single independent seed producer in the U.S. And the idea is really to increase corn yield and sustainability through improvement in photosynthesis, with an expectation for USDA filing in 2021 and over $1 billion product value. And just a final slide, that an observation that close to 100% of calories consumed globally are derived from less than 0.1% of the natural genetic diversity of plants. And that's a lot of diversity to be leaving on the table, and a real opportunity. Thank you very much.
Thank you, Darcy. We'll continue with Jeff's presentation.
Wonderful. Well, thank you. It's a pleasure to be here. My name is Jeff von Maltzahn. I'm a co-founder of Indigo Agriculture, and I'm excited to tell you a little bit about what we're doing today. I'm going to start with the big picture and convince you of what I think you probably already know, which is that we're all working in agriculture, and agriculture is, I think, without question, the world's most important industry. So if you just looked at it from a financial perspective, it would probably be 4th or 6th, and therefore ahead of it would be retail, banking, media, internet, etc. But agriculture is more important than all of those. It's not even close. So I'll start by giving some support for that assertion, and then contrast some of the rates of innovation from those industries with what we've seen over the recent history in agriculture, and highlight where I think the industry is going to go. So agriculture is the only of those industries whose invention probably enabled human civilization in the first place. That's a pretty important, it's a pretty significant thing. So none of those industries would exist if not for agriculture. We wouldn't have banking, we wouldn't have healthcare in the way that it exists now, we wouldn't have the internet, etc. Agriculture allowed us to start to organize human civilization in the way we do today. Today it employs about 40% of the global workforce. So that's 3 billion people around the world who are working in agriculture. And so the other 60% who aren't working in agriculture have those of us working in this industry to thank for that, because they don't have to spend all their time producing the food that they need to sustain themselves. And what we all have in common is that most of all of our ancestors worked in agriculture. So the majority of all of our relatives historically were farmers. Agriculture protects us against more diseases than any single innovation of the healthcare era. And moreover, it sustains every one of us on Earth. So if agriculture goes away, we die. Whereas if the internet goes away or Facebook goes away, et cetera, it may cause us a little bit of anxiety, but it's different. Taking that point a little bit further, agriculture's final product isn't just food, it's us. Meaning every one of us sitting here today is made up of elements that came from the foods that we ate yesterday and last week, and that means we come from the elements that plants on farms around the world gather from their soil and from the air around them and deliver to us in the form of food. So agriculture is the only of those industries whose final product is us. So I think that makes it a truly extraordinary place to be working and innovating, and it's particularly timely for that because we're facing a lot of challenges when we look at agriculture today and when we look at the future of agriculture. If you look at the rate of crop yield improvement over the last 50 years, it's been steadily declining, and that means many of the mainstay technologies that we've relied upon, like breeding genetics, synthetic chemistries, need advances in order to be able to continue to improve or to regain the rates of improvement that we saw several decades ago. And increasingly, we're farming in more difficult environments, higher temperatures, more extreme weather conditions, and with environmental consequences that are significant. So there's remarkable agreement about many of these, yet when you read about them in the newspaper, they're stated very pessimistically. And that's an okay stance to take, but I think the much more compelling perspective is the optimistic one. And that's that we have a chance to potentially dramatically improve the industry and invention that enabled human civilization in the first place, and it's going to touch 10 billion lives in just a couple decades. And we live in an era of technology where we don't have to just focus on incremental changes, but we can ask the question of how can we dramatically improve agriculture so that it's more profitable for farmers, more sustainable, and better for our health. And an important part of that is going to be having more startups. So when you rank those industries, from healthcare at the top to retail and media, agriculture is notable in that it's just starting to get the sort of ecosystem of startups and entrepreneurship that you're hearing about today, focused on trying to fundamentally change some of the biggest challenges in the industry. And the more startups we gather, the better that is for the entire industry, because what startups do is they stay awake all night long and work tirelessly to try to create new solutions for the important stakeholders in their industry. And so I look forward to having many, many companies that become household names in the agricultural column here. And I'm here to talk about Indigo. We celebrated our 4th birthday this year. We started in 2014, and that indicates that we've been really busy. We were started in Boston, Massachusetts from Flagship Pioneering. We've expanded into Argentina, Brazil, Australia, and India. We have just over 400 employees whose backgrounds are primarily from agriculture and technology. We've commercialized microbiome-coated seeds that I'm going to tell you about in five distinct crops. By the end of this year, we'll be on just over 600,000 hectares, and we've raised upwards of $400 million so far. Our mission is primarily composed of 3 pillars. So we're seeking broadly to harness nature to help farmers sustainably feed the planet. And we define that first and foremost by constantly focusing on ways to improve farmer profitability. This is something we think about all the time inside of Indigo. Not how can we sell our products to farmers, but how can we align our incentives and create long-term relationships with farmers so that every single year we can be improving their profits further and offering them new and improved products at a rate that the industry is not used to seeing. And we think it's possible to do that while also improving the sustainability of agriculture and its impact on consumer health. So it helps if you're trying to change an industry if there's a piece of the puzzle that we might have overlooked all along. And in our case, we believe that's the microbiome. The foundation of Indigo's R&D is what we call the plant microbiome. And I'm going to walk you through the path that our science has taken. So first of all, what is a microbiome? It's a relatively new word, but it's pretty simple. It's just a community of microbes that live in a common habitat. So what that means is microbiomes are absolutely everywhere. So they're in the air that we're breathing right now. They're on the surface of the seats that you're sitting on. They're on your clothes, and you're filled with them. And that's not bad. Turns out that because microbes were here 1 billion years before we got here, most of the relationships that they've established with us, with people, are actually vital to our health. So while 100 years ago, most of the attention in medicine was on rare microbes that can cause us illnesses, which is still true, this red chart that you see exponentially increasing is the profound realization in science over the past 20 years that at every instant in our lives, even when we're sick, the vast majority of microbes that live in our gut and live on our skin are actually really important to our health. They're defending us from pathogens, they're regulating our immune system, they're affecting our metabolism. And the foundation of Indigo was based on a really simple insight, which is that not only are humans replete with these relationships with microbes, but it turns out if you take any plant in the world and cut it open, they all have microbes living inside of their tissues. So we've known that for a long time with soy and other legumes that have nitrogen-fixing microbes in their roots. That's been known for 100 years or so. That turns out to be just a little piece of this biology, though. So additionally, every stalk of corn in the world, every flag leaf on every wheat plant have microbes living inside of those tissues. Every tree in a rainforest. And if you think about that from the microbes' perspective, living inside of a plant is an amazing home. So think about a plant living in the desert. If you're a microbe and you get to live inside of that plant's tissues, wow, you're kept wet, you're given sugar, you're fed on a regular basis, you're protected from the environment. And if your alternative is to try to survive on a grain of sand in the intense sun and arid conditions, then you're going to be motivated to try to figure out anything you can to help the overall survival of that plant. So at the start of Indigo, we asked the question of, wow, maybe this is just a new vantage point or a new perspective on plant biology, period. Maybe there are microbes that have evolved to help plants survive every stress. So not just nutrient acquisition or not just nitrogen fixation, but protection from insects, fungi, bacteria, viruses, drought, heat, cold, salt, micronutrient deficiencies. Maybe there are cures or solutions to all of those that are just sitting there in these special microbes that live inside of plants. So we started testing that hypothesis, and we were amazed by the results. So this is an example of one of the first sets of experiments that we were doing in Indigo. We started going into farmers' fields and finding those rare plants that in extreme drought, for example, are able to survive. You know, every farmer here, anybody who's been in an agricultural field will appreciate that even though you're trying to uniformly control the environment, sometimes you have these extraordinary plants. You can't really explain why it's doing so well. And we asked whether the healthiest plants in fields under stress might have special microbes inside of them that we could pull out, culture, and then transfer to agricultural crops via seed coating and perhaps evoke the kind of response that you see on the right. So this is in fact an example of this. The difference between the control formulation and the plus indigo soy plants there on the right is just the addition of one microbe on the surface of those seeds at the time that we planted them. That microbe we discovered from going out into agricultural fields and sampling from extraordinary plants. So these plants aren't 1 or 2% different in yield from their neighbors. They are infinity different or hundreds of percent different in health, biomass, and in resulting yield. And remarkably, even with single microbes from those lottery winners in a farmer's field, you can impart the kind of effects that you see there on the right. So we've now built a large discovery capability around this. It all starts with sampling from now tens of thousands of what we call survivor plants that are able to thrive under extreme conditions of stress in farmers' fields. And then we use computational approaches, sequencing, and then a high throughput set of experimental approaches with feedback loops to learn across each step of this to bring products through to commercial. So if you think about it, plants on farms around the world are sampling from the trillions of microbes around them and individually establishing their own microbiome. And our job is to learn from those at the fastest rate that we can so that we can deliver those solutions to farmers at scale. And because the timelines of this are short, because of the tools that we use in data sciences, we're able to improve our commercial products every year. And we're committed to continue to do that. So for those farmers in the audience who are used to seeing a product get released and then have it not change for 5 years or 10 years, Indigo will be different. We will be improving our products every year that we're releasing them into the market. And this is our early track record for doing that. So across each of the crops that we've commercialized, we've seen commercial yields of over 5% or over 10% improvement. The two crops we're most advanced in are cotton and wheat. And in 2016 and 2017, you see 11 and 8% yield improvements for those crops. This year in 2017, we improved both of those to a 14% yield improvement and a 13% yield improvement. So these are crops where the annual rate of improvement is about 1%. And that comes from all innovation taking place on farms, all innovation taking place in chemistry and breeding. And we think this is a glimpse of just how important the microbiome is going to be for the future of agriculture. It's almost a 5 to 10 year jump into the future of yield by the addition of 1 or 2 microbes to the surface of those seeds. Over the past couple months, we've been examining the yield that's been taking place on a subset of indigo commercial acres. And we started doing some experiments to see, hey, can we see this from outer space? Can we look via satellite and detect the difference between indigo wheat performance and neighboring fields? And remarkably, this was pretty easy to do. So specifically what we did is over 25,000 acres of indigo farmers, we tagged neighboring fields, which were their neighbors, who did not plant indigo wheat, and we examined the health of the crops and the resulting yield over the course of the season. So everybody wants to outdo their neighbors, whether it's driving across the county, you'd like your field to look the healthiest. It was pretty amazing to us that it appeared that our products this year not only improved indigo performance relative to one's neighbors, but it improved it so substantially you could see the differences from outer space. And you see a range of the indigo fields and control fields illustrated. Technology innovation, but it's business model innovation. If you look at the technologies that have been introduced over the past 30 years, they've made a really big difference in agricultural productivity. They often haven't improved farmer profitability. In fact, in the United States, the profitability of farmers hasn't really changed at all over the past 20 to 30 years, despite those advances. And so it's central to Indigo's mission that we focus first and foremost on farmer profitability. And we're constantly thinking about business models through which we can do that more effectively, align our interests with the interests of farmers, and not just establish a one-year relationship where we're selling a product, but establish a relationship where we can work together to constantly improve the underlying yield of their crops. And we do that with an indigo-treated seed model where you can buy indigo-treated seeds. We also have a production model where we partner together with farmers to be able to share risk and seek to optimize decisions throughout the season and assist with financing to be able to make the entirety of a farm higher performing. And then we have a set of partnerships with farmers currently in the United States that you'll hear from us soon that we'll be expanding into Argentina, where we pay farmers to be testing new technologies, our technologies, but also technologies of other startups. We think a huge barrier to entry of new technologies is just the risk that farmers need to take on to experiment in the first place. And so we're deploying sensors and instrumenting farmers' fields so that they can run better experiments and get access to cutting-edge technologies across every new technology category in agriculture. So more to come on this, and both to farmers and to innovators in the audience, anyone who's interested in working with Indigo to get their product tested and brought to market at larger scale or more effectively, we're excited about those relationships. And we're excited to be here in Argentina. This is the first country we expanded to internationally. We've had our operations here for over a year. We launched 2 products last year. This year we're active in all 4 of our crops, from indigo soy, corn, cotton, and wheat. So the microbiome improvements that I described to you earlier in the talk are now available to Argentinian farmers. And this is just the very beginning. We are just starting what we think is a Mount Everest sort of expedition in the microbiome. And with the partnerships we're creating with farmers and indigo research partners and third-party relationships with other technology innovators, we believe we can help bring an extraordinary number of advances on an ongoing basis into farming. So the kind of relationships that we're excited about with farmers is where they expect from us that every year the productivity of their farm and the amount of value that they're able to capture is increasing in a meaningful way. With that, thank you very much. Gracias.
Bueno, vamos a empezar con las preguntas. Estoy recibiendo...
We will start with the questions. I'm receiving questions from the audience, but before I will ask to ask some general questions I jotted down during the presentation while the two presenters use the headset so they receive the translation. I have a question for Jeff to start is, can you tell us something more? How did it occur to you and your colleagues to found Indigo, and what was your experience like an entrepreneur? In such a short time, you were able to come up with a company that you have just introduced to us.
Let me test and see if this is working. Great question. You said that it's such a short period of time. It feels like it's been about 100 years since we started Indigo, and that's not unique to Indigo. But that's sort of a feature of startups, as you know, as we all know. We started Indigo out of Flagship Pioneering. Flagship is an innovation firm in Cambridge, Massachusetts, that historically has had most of its invention and startup creation take place in healthcare. And it was those roots that gave us the perspective that the plant microbiome might be an extraordinary new area for agriculture, and particularly that the microbes that live inside of plants, which 6 years ago or 7 years ago when we started the basic research that became Indigo, was still sort of controversial outside of nitrogen-fixing microbes. We received a lot of perspectives that it was crazy to think that plants had microbes on the inside, and you know, that even if they were there, it was probably a contamination event or a transient thing. But to us, because we'd spent 6 years before that focused on the human microbiome and the remarkable science and impacts on medicine that is likely to entail, it was simply profound that if plants have microbes on the inside of them, then that must be an extraordinary collaboration where the plant benefits from the microbe benefits from the plant, and given the rate at which microbes can evolve and the importance of the plant's survival for them, that these microbes might be like a software for plants that would both be rapidly capable of evolving and maybe would be transferable in the way that human microbiome science has found microbes that live in us to be. And so perhaps you'd have a more powerful, more natural, and a more rapidly transferable technology in the form of these rare microbes that live inside of plants. So we started the company on the basis of that, but at every turn, as we've seen the biology start to show extraordinary things, we've been asking the question of, what's the biggest version of this area of science and technology, and how do we try to build the most important company that we can? And so that's driven the evolution to working with tools like satellites and working with other startup companies and evolving multiple variations on business models to partner with farmers, really driven by the question of trying to aspire to be the best version of what we think this science can offer.
I was going through the questions we got through WhatsApp, and there was one that is a really good follow-up on what you have just indicated, no? In terms of Indigo is well known for its fundraising ability, no? It's been headlines, at least here. And there's a question here that asks around how much of that sex appeal, if you will, comes from the parallelism between the human microbiome to the plant microbiome sort of space that you just alluded to, versus sort of the business model innovation that you also alluded to.
Oh, great question. I thought it was just going to be the first part, meaning the human microbiome. And that helped us start the company in the first place, but everything we've done since has been based almost entirely on data in crops and in fields. So the scientific appeal of the human microbiome only gets you so far. You know, I would say, if you zoom back as to why startups need money, when you're working in an area of new science and you're thinking about creating a company, you're always going to be limited by, I think, one of three things: either money, or talent, which you could lump the two together and call it resources, or your opportunity itself. And as we realized that the scientific opportunity in the microbiome was very large, it led us to realize that we were unlikely to be limited by that science in the near term, and that we had the ability to be able to rapidly discover and commercialize products because of the regulatory pathways that exist around microbes. And so therefore we were going to be limited by resources, either capital or talent. So we've put a lot of attention into it. And while the amount of money we've raised is unique in some ways to startups in agriculture, it's still a far cry from the amount of money that companies in the other industries that I described raise. Internet companies raise billions of dollars. And I think, in fact, it's really important for agriculture that startups get access to the kind of capital that it takes to do extraordinary things in complicated industries. And as we progressed, we realized that our opportunity wasn't just science, that the opportunity was going to be limited by our ability to access the market. And therefore, we had to think really creatively about new business models. It was obvious to us that were we to try to work with the big companies, the pace at which we'd be able to innovate and affect farming would be slower than if we could find a way to directly work with farmers. And then it became obvious to us that we needed to rethink the classical business models associated with putting technologies into the hands of farmers who are bearing all the risk for that. And if you have them exclusively pay up front and you make a lot of promises, you put them in a position where they're much more likely to be skeptical than if you can share risk with them, guarantee upside, and some of the things that we've tinkered with on our business model side. So I don't quite know the answer as to which has been sexier or more important, but I think they've both been vital. In agriculture, you have to both solve for complicated science in a meaningful way, and also be able to figure out how you're going to be able to access the market in a meaningful way.
Thanks. Darcy, ¿cómo pasó Benson Hill?
How come that Benson Hill was a company devoted with basic research in photosynthesis, which is the result of the name of the company? How did it switch to a company that analyzes artificial intelligence data, and how that is translated in the business model of the company looking into the future?
Maybe I'll start with the business model first. I mean, Benson Hill, doesn't sell its technology. It really it tries to partner and collaborate quite purposefully with its partners. And the reason for that is a combination of things. I think, for example, in the case of building out the breed data platform, we get feedback from customers about what's missing in the platform, some calculations that they see benefit to that we can build into the system. And so we quite purposely have a quite integral relationship between the partners and the technical groups in the research and development area, both the breed and the genome editing. But it's not exactly accurate that, the roots of the company were in photosynthesis and identifying gene traits, and the intention was always to
both build out our own capability to license those traits over time, but also to be having partner companies testing those traits in a broad range of crops. The two of the three co-founders, one was Matt Cripps, who I mentioned, and the other two were Tom Britnell, whose expertise came from photosynthesis from Cornell, both of whom are at the Danforth Center, and then Todd Markler, whose background is bioinformatics. And so the expectation was always to complement the development in gene trait capability with a capability in predictive engine as well for the bioinformatics. The reveal application that I mentioned, which identifies the traits, was always planned as part of the core strategy into the machine engine. And then the capability in genome editing really evolved mostly because of the difficulty in IP and licensing from the original established players in Cas9 and CRISPR 1 and 2.0. And that capability proved out to be very successful with the team in R&D, and they've since been able to expand that, along with the accelerated demand in genome editing in general in the space.
I'll ask you a follow-up question that is coming from the audience here regarding the European Union ruling 2 weeks back in terms of the gene editing and that being regarded as GMO in a particular instance. Would you comment on that, on how that might affect the business?
Yeah, I mean, I think we consider it a setback, but a mild one. We don't expect it to affect the businesses in North America or actually several of the principal markets in South America either. But and we have collaborations with European firms, and their reaction to the ruling really hasn't changed their interest and commitment to at least be working with the technology.
Una pregunta de la audiencia para Jeff.
This is a question from the audience for Jeff. Considering that part of the solution comes in the microbes or biological products that would benefit the yield in a plant, what is the strategy of intellectual property related with this type of inputs?
Another excellent question. So when we started Indigo, it was in 2014, and in the United States, there had just been a ruling called the Myriad Genetics case, which brought into question the patentability of natural products. And it was a surprising result to many industries in which natural products have been patentable historically. So we knew that we needed to take an overall strategy to innovation and intellectual property that would deeply take that into account. And I think as a result of the amount of thought that we put into it, we've been very successful in securing intellectual property across all of the products that we've brought to market. And we've done so internationally as well. So we have over 250 patent applications and issued patents collectively. And we continue to very actively convert our science into intellectual property filings. Additionally, I think we're entering an era of biology that mirrors some of what software has gone through over the past 20, 30 years, which is that if you just rely on intellectual property, you leave yourself vulnerable to changes in intellectual property law and vulnerable to the increased pace of biology, so that almost any discovery might have 1,000 cousins that someone else could pursue if they discovered them. And so an important part of the Indigo culture and our mindset around intellectual property and competitive advantage is just that we should be pushing ourselves to be innovating faster than anybody else in this industry, and establishing collaborations with partners that can encourage that, whether they're farmers, whether they're other startups, whether they're other technology providers. And so I think patents are just one part of the story. You really have to have a rate of innovation that is a material advantage.
Bueno, la verdad es que hay como 22 preguntas más.
I have more than 22 questions. I hope I'll be able to give them later on to the panelists so they are aware of what are the concerns of this audience. We are running out of time, and so that we will close the panel with these questions. Thank you very much for your interest in these topics, and a new round of applause for these international guests.